Hi, thanks for watching this video on solving absolute value equations. By the end of it, you should be able to solve an absolute value equation. But before we get to actually solving equations, I want to just look at our definition of absolute value. I like to think of it as that distance away from zero on the number line. So when I ask us to calculate these different absolute value problems, I look at the absolute value of 8 in this first one, and I really like to think of it as how far is 8 away from 0? Well, I think everybody knows that the answer is 8. 8 is 8 away from 0. Now, if I get a little bit bigger number, and I'm going to flip it over to a negative, and I ask how far negative 75 is from 0, well, we think in our head where 0 is, where negative 75 is, it's 75 units away. It's not a very good looking 5. Try that again. 75 would be our absolute value of that. And last but not least, I give you a negative fraction, and the distance, negative 7/12 from 0, is just a positive 7/12. So most of us think of absolute value as taking a positive, keeping it positive, or taking a negative and turning it into a positive, because again, it's talking about distance, and distance is positive. So when I come here and I look at this absolute value equation that we have, and I want to solve this, first I want to think about what is the meaning. So I think back to my definition of absolute value and apply that to this situation. So I wrote down, this little equation is really saying the distance x is from 0 is 3. It's like our equal sign. And then the absolute value of x part here, that's right here. The distance x is from 0, and then we have our final answer of 3. That's right there. So it's all broken down. Now, if I come in and look at this as a visual approach, the distance x is from 0. So from 0. So I'm looking at, here's my starting point in 0. Now, some numbers are 3 units away. Well, if I go 3 units away, if I go 3 units this way, I end up at, well, positive 3. If I go 3 units this way, I end up at negative 3. So when everything's all said and done, I have solutions of x equal to negative 3 and x equal to positive 3, which hopefully will also make sense, because if you go back to our original equation and we put negative 3 in for x, well, the absolute value of negative 3 is positive 3. It checks out. If we put this positive 3 into our original equation, the absolute value of 3 is also 3. Now, another way that I like to think of it is, I kind of went back to the visual approach. We can also go back to the absolute value. We know that this number inside here either has to be a positive 3 or it has to be a negative 3, which also matches up with our two solutions that are down here. Now, let me give you one that's a little more in depth, not too much. Now, in this one, again, I'm going to go back to what does absolute value mean? Oops, there we go. And I wrote down, in this case, it's the distance m is, or excuse me, the distance m is from 6 is 4. That's what this little equation is telling us. So think about that. The distance m is from 6. So in this case, 6 is my starting point. I have some numbers that are 4 units away from that. So if I go 4 units to the right, well, where am I at? I'm at 10. If I go 4 units to the left, I'm at 2. So I come down here and I go, well, list the solutions to that equation. I end up with m equal to 2 or m equal to 10. Now, again, I like to make sure that this actually works. So I take my 2 in my head and I plug it in here. Well, 2 minus 6 would put us at negative 4. Absolute value of negative 4, yes, is positive 4. I take the 10 and I put that into the equation. 10 minus 6, that's 4. The absolute value of 4 is 4. So this example here, I looked at again in a visual. But if I go back to absolute value, I know that this absolute value symbol right here is going to take whatever's inside of it and make it positive. Therefore, I think that, well, all of this stuff in here either has to equal 4 or it has to equal negative 4. Okay? So I want you to keep that in mind as we move on to these next equations that we're going to solve. This one. So this one, I have a hard time trying to create the visual on the number line because now I have this fraction involved and there's multiple things in the numerator, the 5 in the denominator, and it's a lot more difficult to think of this visually. So now I go back to, what does absolute value mean? So again, I come back here and I go, well, that stuff inside the absolute value symbol either had to be the positive of what was on the right side of our equation, or it had to be the negative of what was on the right side of our equation. So moving here, I'm going to look at all of this stuff inside this absolute value. It either has to be a positive 2, or it has to be negative 2. Now think about that. We just said everything inside what I have circled in red, so I'm going to look at it as 3n plus 4 over 5. It either had to equal 2, or everything inside of there had to equal negative 2. Now, there's two little equations that we can solve. We've solved things like this before. This one's a little messy because it has fractions in it, but it's definitely solvable. So I go through, I'm going to work on the one on the left. I don't like the fractions in there, so I'm going to eliminate the fractions. It says divide by 5, so if I multiply both sides by 5, my 5's are gone there. And now we're left with 3n plus 4 equal to 10. And as I keep solving my equation here, I'll subtract the 4 from both sides to find out that 3n equals 6. And then last but not least, if we divide both sides by 3, we find out that n equals 2. And again, if I take this 2, bring it up to my equation, now I'm just going to mentally put it in. So I'm going to look at, I have 3 times 2, that's 6. 6 plus 4 is 10 in my numerator, and 10 divided by 5 is 2. Absolute value of 2 is 2, therefore 2 is a solution. Now I have this other one on the right side that I have. I've solved this one. And again, I'm going to get rid of my fraction right away. My 5's are going to divide out. I'm left with 3n plus 4 equal to negative 10. Continue to solve by subtracting 4 on both sides. And now I end up with 3n equal to negative 14. And then last but not least, divide both sides by 3. This time we get a fraction. We find out that n equals negative 14 over 3. Does this one really work? So I'm going to come up here. Well, if I put negative 14 thirds in right away, I first have to multiply negative 14 thirds times 3. Well, think about that. I have a 3 in the numerator, and my solution has a 3 in the denominator. They're going to divide out. So this first part that I have underlined in black is now negative 14. And then the negative 14 plus the 4, that's going to put us at, let's see, negative 14 plus 4 puts us at negative 10. And negative 10 divided by 5 is negative 2. And then last but not least, we have to take the absolute value of all that. Absolute value of negative 2 is positive 2, and it checks out. Maybe I should have written that down. If you want, you can plug it back in yourself, and you'd figure all that out yourself. Let me give you another one. This one's a little different than the previous ones because now you'll notice that I have the absolute value along with another constant on one side. And all the other ones, the absolute value is all by itself. So I have this little hint here that anytime we have an absolute value equation, I think the first thing you want to do is get the absolute value part all by itself. So we need that to be all by itself. And if that has to be by itself, that means the 8 cannot be there. So if I subtract 8 from both sides, now I have, oops, I'll just start that over. I have the absolute value of 2c equal to 12. And again, I'm going to think about what this is going to tell me. That tells me that all of this in here either has to be positive 12 or it has to be negative 12. So if I take this 2c, one time I could think of it as equaling positive 12. But the other time I can think of it, I'm going to go like this. We're going to go, it's either going to be a positive 12 or it's going to be a negative 12. Okay? Because the stuff inside here either had to be 12 or it had to be negative 12. One of the two, and then it'll make the equation true. Now I have two little equations that I can solve. So my first one is going to come here and divide both sides by 2. And I just figured out that c equals 6. My other one, divide both sides by 2. I just figured out that c equals -6. Okay. Again, if we go back to that original equation, if c is 12, or 6, excuse me, 2 times 6 is 12, absolute value of 12 is 12, plus 8 is 20. If I put a -6 in there, 2 times -6 is -12. Absolute value of that is +12 again, and 12 plus 8 is 20. It checks. So I have my two solutions. So hopefully you're kind of recognizing that a lot of times we get two solutions when we have an absolute value equation. Now, does that always happen? Well, let's take a look at this example. And again, my hint is going to be, let's isolate the absolute value part. So the first thing that we have to do in this one to isolate the absolute value is we're going to have to get rid of the 12. So I'm going to subtract 12 from both sides. Now I have 3 times the absolute value of d equal to 0. But my absolute value is still not all by itself. So I'm going to divide both sides by 3. And now I have the absolute value of d equal to 0. Now most of the time, on my other equations, I just took, I'm just going to go back and show this. Maybe. There we go. So when I got to this point right here, we took and broke it into two equations. We said the stuff inside the absolute value, the 2c, was either equal to the positive of what's on the right side of our equation, so 12, or it's equal to the negative. Now in this one, if we were to do that same thing, we would say that d equals +0 and d equals -0, which really doesn't make sense because 0 is really neither positive nor negative. It's 0, it's in between. So we don't have to worry about the 2. I'm just going to go like this. I'm going to get rid of that positive. And we just end up with d equal to 0. So sometimes our absolute value equations will only get the one solution. And now my last one. I have the absolute value of e equal to -9. Absolute value is already by itself, so some of us would think, well, let's break it into two equations. Okay, so if we do that, we basically say e equals whatever the right side's equal to, and we'd say e equals the opposite of that, which is 9. That's what we've done in all of our other examples. But does this really make sense in this case? So if I were to take this -9 and put it back in there, what's the absolute value of -9? It's 9. Well, is 9 equal to -9? No, so I know that doesn't work. If I were to take the 9 and put it in there, maybe that one's the solution. Well, the absolute value of 9 is 9, and 9 still doesn't equal -9, so this one doesn't work. Some of you are thinking, do I really need to show that work? My hope is no, okay? Because I'm going to come back to this original equation. Now notice what it's saying. It's saying the absolute value of e. So it's saying some number is -9 units away from 0. Well, is it possible to be a negative distance away from something? No. So from the get-go, this equation really doesn't make any sense. And if you see that, you can just instantly write no solution, because it does not have a solution to it. All right? And there is our lesson on solving absolute value equations.